Hello, my name is Ehsan Salehi, one of the field application engineers for LDRA and also a verification authority lead for FACE standards for LDRA LCS division. In this presentation, I will be talking about DevSecOps, best practices for the validation and verification of the safety and security critical embedded software. The growth of a smart and connected product is fueling the demands for DevSecOps across the industries that have traditionally relied on isolated embedded systems. As the aerospace industry transforms to adopt technology, including Internet of Things, artificial intelligence, and machine learning, software developers and testers are searching for agile, scalable process and practice that results in a safe and secure embedded software. Popular practice includes shift left by testing early and often adopting continuous integration by automating the build, test, release process, and ultimately practicing DevSecOps to bring together the worlds of developments and operations while applying safety and security as the best practices at every stage of the process. On the surface, several of these practices may appear to contradict some of the basic principles of developing safe and secure embedded software. Successfully applying these practices requires changes in approach and thinking of both software developers and testers. This presentation will explore the challenges of successfully applying DevSecOps and introduce several best practices for the validation and verification of safety and security critical embedded software. As shown in the picture, a cybersecurity DevSecOps lifecycle phases. As user can see, the process and build, test, and develop, which are the essential tasks for any software practice, can be done as a cyclic, agile format. The plan and the release of the software are the two elements which they can initiate the cycle, and how the output of result of the projects is displayed and stored. Also, on the operational point of view, from the delivery all the way to the needs for the new plan, there will be a cycle which can take place simultaneously. On the user sides of the project, deploying the application, ensuring the application is operable, and also monitor the results and reporting the feedback can help to initiate plan for the next phase of delivery. When looking into these cycles, the necessity of the DevSecOps tools will become more superficial. Using a container where it can help multiple developers check in their code to the repository, executing static analysis, dynamic testing, gathering reports, and check all the requisite for the delivery before it's sent to the customer in a timely manner is the great advantage of these type of tools. There are three major DevSecOps maturity models. One is improving software lifecycle security and safety by shifting left. Second one is the improving software development efficiency with the continuous integration. And third one is achieving security at the scale with the DevSecOps. These terms build on each other going down to the list. And they can provide entry points and progression for users and developers at different level of DevSecOps adoptions or maturity. Enabling software developers to do more testing during the development rather than leaving most of the testing to be done during the integration and test is the purpose of the shift left testing. This will accelerate the use of coding standard compliance static application security testing, or what called SAST, performing quality testing, which produce clarity, maintainability, testability, executing unit testing or benchmark testing, and finally get the credit for the testing that has been done to display structural coverage analysis. While using the targets and IDE integration are the important features that can be used during the shift left testing method. Shift left testing method can also reduce the time and the effort to find and fix the defects. It can help to configure testing to provide developers actionable information and easily understand the reports. In order to understand the effects of the shifting left approach, we need to talk about the traditional software development lifecycle, as you can see in the figure here, the waterfall approach, where requirement and analysis and specifications is the key to develop the lower level requirements, and finally to develop the source code. And on the verification side, the code can be tested by the unit test model and the modules for unit testing. Then for the high level requirements, software integration testing or system testing is taking place. And then acceptance and the maintenance of the software testing will be performed to support the product. Software development lifecycle is a step-by-step approach to developing any software that deals with the safety and security. Waterfall approach model is now becoming a barrier these days, as the agile methodology becoming popular. As we can see here, different typical software development life cycles involved with planning, design, code development, and then testing, deployment, and maintenance. Shift left approach suggests moving test activities to left rather than earlier in development lifecycle. Therefore, the tester does start the test deployment and development in a much earlier stage. This can also advocate more for automation, since the tester will be required to run many repetitive testing as the project progresses, and if there is no automation, the repetitive testing can take a long time. As shown above, the activities such as the static analysis, static application security testing, or SAST as we talked before, executing the quality review, executing test cases on a target, regressing unit testing, generating unit testing, and integration testing, they all can be done in an automatic way. So therefore, automated testing is highly recommended. And the needs for automation here can help us to understand why DevSecOps approach is being promoted. To simplify iterative and repetitive tasks such as regression testing or static analysis performance, or to perform the incremental development, continuous integration approach will aid greatly. With continuous integration testing, or CI, user can perform a test on an operation in a file, or a group of operations in a file automatically. Continuous integration method also encourage the use of multiple testing tools to improve robustness, while with the traditional manual approach, these features were hard to implement, if we don't want to say impossible. On the other hand, the automation of the workflow defined for parallel development can help to uniform sets of the test, which can improve quality, and support to execute the pull requests automatically, and therefore merged and finally release the software. One last thing, a customizable pipeline helps to integrate different stages of integration by configuring analysis to match the goal of each stage. It also helps to perform benchmark testing and executing unit testing or coverage analysis to obtain the software and structural coverage results needed for any standards such as DO 178, ISO 26262, or other industry standards. The sketch above shows an example of using a verification and validation tool such as LDRA tool suite in a DevSecOps container. In this case, Microsoft DevOps Azure. As seen above, the LDRA has to be installed in the container rather than the local PC, which is using the container. The reason behind this is the fact that Azure DevOps is fully isolated from its host environment. The container helps to ensure security precaution behind the development environment, and developers are safe to executing test cases, developing source code, and check in and check out source code. LDRA toolsuite needs to be able to access to the FlexLM server to check the license when analysis is performed. Therefore, the FlexLM locations and the IP address needs to be in the range specified and accessible by the container. The shared volume is the location where all the results of analysis and instrumented file and the reports can be stored and displayed. When using embedded development, ensuring the cross-compiler location targets are all accessible by the container are the key in order to execute the test case on the targets when performing dynamic analysis or regressing the unit testing. Source code repository will also need to be reached from the compiler prior to setup. The steps shown here will help to set up a pipeline in Microsoft Azure as example. To create a job using LDRA static analysis, user first need to create a task in a pipeline to import a project from the repository into the container. So that's the first step. The next step is to creating a job to insert tasks, and classic job will be recommended if the user is not familiar with the YML language. Job type needs to be selected next. If not sure what job types should be used, empty job should then get selected. Inside of the job, user will need to select the pool which has been created and configured when executing the configuration of container. When creating tasks, user may add multiple tasks which can run in a sequential mode. These tasks can be building the project, creating a set to be used by LDRA from the build process, and or performing static analysis, dynamic analysis, executing test cases, or regression of unit testing, which all are supported by LDRA. Once all these tasks have been created, user can execute pipeline and be able to view the job summary. The screenshot here is the view of the task list inside of the pipeline in Azure DevSecOps, as it is handful of tasks can be placed for a pipeline to be executed. Therefore, in parallel multiple pipelines, user can execute multiple pipelines at the same time simultaneously, depending on the type of the license condition for Azure DevSecOps. The screenshots here show the results of a static analysis, test integration reports on a multiple source code, and the full set of the a full set of a project using LDRA tool suite. These reports can be all displayed in a pipeline output of a Microsoft Azure job. As seen, this is a huge advantage when developing a medium or huge size project, where all the developers are developing and verification engineers are creating test cases for the source code that are being checked into the repo. And developers can see the result of the test, can see the result of the static analysis, and update the source code simultaneously. Azure can display reports in many different formats to enhance the usability and visibility of the task execution. These features help users to provide desired results and being able to present as an official format for the configuration management purposes. As seen in the screenshots above, there will be number of the tasks to be published on the test results in Microsoft Azure DevOps. The test results can be JUnit, XUnit, CTest, HTML, or etc. Meanwhile, a tool such as LDRA should be able to generate JSON, JUnit, text, HTML, or XML, or any type of these reports that a user would like to select to be shown the results to the rest of the team. Just need to mention, LDRA will be able to generate JUnits, JSON formats, and others by creating and executing a script from the XML reports. Some of these reports are available inside of the LDRA tool suites for user to be able to execute them. In conclusion, need for rapid software integration while maintaining security had become essential rather than a good option to consider. The DevSecOps can help with bringing the development and operation together. It also can join the secure environment to developers and test, improving efficiency, and finally improving the automation from start to the end are all the benefits of using DevSecOps applications. Thank you so much for listening to me. If there is any questions, I'd be happy to answer them. Also, if you would like to contact us, you can email us at info@ldra.com. You can also visit our website, ldra.com, to get more information about the software product LDRA offers and different type of certifications and standards we are supporting. Please follow us on YouTube, LinkedIn, Twitter, and Facebook to get updates for our latest projects and products. Thank you.